Okay, this is going to be a review of our Unit 5 notes in preparation for your test that will be on Friday. I may sound a little stuffy because of my nose surgery, so please excuse that. And hopefully this will be a way, this will not be very exciting, but hopefully this will be a way for you to review the notes in preparation for the test that you're going to have on Friday. Alright, so Unit 5 is on force. And I'll just go through the notes line by line like I would do in class in review for a test. Okay, so what is involved whenever the acceleration of an object changes? And the answer is forces are involved whenever the acceleration of objects change. Next question, what is a push or a pull exerted on one object by another object? And the answer to that, of course, is force. And you're given a few examples of force, or many examples of force, in these notes, and one example that you're given is gravity, and we'll actually spend more time on gravity in a coming unit. What is the only thing, or actually before that question, also you should remember, and this is part of your catechism as well, that force also has both size and direction. When we describe force, we always describe it with not only size, but also the direction that is applied. What is the only thing that can change the acceleration of an object? The force is the only thing that can change the acceleration of an object. And remember, when we are talking about acceleration here, we are talking about any change in the object's motion. So acceleration is a change in object's motion, whether the object is speeding up or slowing down or changing direction. So what is the only thing that can change the velocity of an object's travel? And actually probably should word that as speed, but in your notes it is velocity. So a force is the only thing that can change the object's velocity. What is the only thing that can change the object's direction of travel? And again, force is the only thing that can change the direction of an object's travel. What are the SI units of force? The SI units of force are, of course, the newtons. Their symbol is a capital N. We've worked with them quite a bit now, so hopefully that will be an easy question if it shows up in the test. What do all forces act on? All forces act on objects. Remember, and I'll give you a couple just statements here to help you think about this. When you think about pushing, the word push implies that you are pushing something. You're applying a force to something. And the same for the word pull. When you pull, that implies that you're actually acting on some object. You're not. Here's what it is can you push nothing? No, you can't push nothing. Can you pull nothing? You can't pull nothing. Now, just because you do push on an object or pull on an object, does that mean the object is always going to move or change its direction? And the answer is no. Just because a force acts on some object doesn't mean the object's going to move. You can push on a tree or a wall all day, and you're probably not going to move it if you don't. And you have to apply enough force to do so. Another example: you're sitting on your chair. If you're just sitting in your chair right now, does that cause the chair to move down? And the answer is no, because the force pushing down on the chair is balanced by the force of the floor pushing back up on the chair. Okay, we'll move on to the next slide. Next question. Can all objects that exert or receive a force be seen, or can all forces be seen? And the answer to this is no, not all objects that exert or receive a force can be seen. You cannot see the force exerted by magnets, for example, and what causes them to pull towards iron-containing substances. And also, when you look all around you, you are surrounded by air, but can you see the air? And can you see the force of gravity that holds the air near the Earth's surface? And of course, we cannot see air, we cannot see gravity, but we would not deny either of their existences. We know that they're there. Okay, when we're looking at objects, is there usually just one force acting on an object, or more than one force? The answer is usually there's more than one force acting on an object, probably almost always. So when we have more than one force acting on an object, we can combine all these forces together. So what is the combination of all the forces acting on an object? And the answer is net force. And how do we find net force? We find net force by adding up all the forces acting on an object. And when we calculate net force, what must be accounted for when calculating net force? The answer is direction. Direction must be accounted for when calculating net force. And to keep things simple, because we're in 8th grade in this class, what we're going to say is we're only going to be calculating net forces when we're moving in one linear direction. So the forces will always just be opposite each other. We won't have any forces that are perpendicular or at some angles to each other. We'll just have forces moving generally from left to right or up and down. So in this class, what we'll say, when forces move from left to right, what kind of number will they have assigned to them? Well, when forces move from left to right, they will be assigned a positive number. And when forces move from right to left, what kind of number will they have? They will be assigned a negative number. And this will help us to calculate net force. And the positive or negatives will simply indicate direction of travel. Okay, now when we are calculating net force, if we have two forces that are acting in the same direction, we will find that they will always add up to a larger absolute value than either of the two individual forces. Now, this may not be true if you have more than two forces, but if you have just two forces acting in the same direction, what can we say about their absolute value? We could say that their absolute value, or the absolute value of the force, will be larger than either of the two forces. And we talk about absolute value because if they're moving from right to left, they'll have a negative number. So negative 30 would be a smaller true number than like negative 15, but it's a larger absolute value. Okay. Now, if we have two forces that are acting in opposite directions, what can we say about their absolute value, the absolute value of the net force? And what we can say is that the absolute value of the net force would be a smaller number, be a smaller absolute value. And that's the examples that we see here with the two kids pushing the piano, or one's pushing, one's pulling the piano. The net force is larger, has a larger absolute value than either force that the two kids are applying, and the two dogs playing tug of war. The net force has a smaller absolute value than either of the two dogs because they're pulling in the opposite direction. Okay, next question. What can you determine if you know the net force on an object? And what you can determine is the effect of the net force on the motion of the object. And this is because net force, what does net force tell you about the forces acting on an object? And net force tells you whether or not the forces on an object are balanced or unbalanced. Okay, so we'll talk about what these things mean here. So when the forces on an object produce a net force equal to 0 newtons, what is that situation? Well, that situation is called balanced forces. When you have balanced forces, the net force on an object will be 0 newtons. And what can we say about balanced forces and the motion of an object? And what we can say is that balanced forces will not cause a change in the motion of an object. So however an object is moving or not moving, if it has balanced forces, its motion will not change. And there are many objects around us that have only balanced forces acting on them with a net force of 0 newtons. So what's an example of an object that has a balanced force, that has balanced forces acting on them? And it's easy to point out objects like your desk. Your desk does not move because force of gravity pulling it down is balanced out by the force exerted back up on the desk by the floor. And really, any object that is not moving has balanced forces. So if we look at an object and we see that it is not moving, we can say that it has balanced forces. Those are the easy ones. It's a little more difficult with objects that are moving. We'll get into that in a second. So with moving objects, can moving objects have balanced forces? And the answer is yes. Moving objects may have balanced forces. Moving objects may have balanced forces as long as their motion is not changing. If their motion is not changing, then moving objects can have balanced forces. So give me an example of a moving object that has balanced forces. And we'd say if there is a car that is moving at a constant velocity, that means it is moving at a constant speed and it is not changing direction, it can have balanced forces because the motion of the car would not be changing. It'd be moving at a constant speed and in a straight line, so it would have balanced forces because its motion would be constant. All right. Now, what is the situation when the forces acting on an object produce a net force that is not equal to 0 newtons? Well, this is what we call unbalanced forces, when we have a net force that is not equal to 0 newtons. And it could be greater than 0, or it could be less than 0, depending on the direction. But when it's not equal to 0, that's an unbalanced force situation. What can we say about unbalanced forces and the motion of objects? What we can say here is that unbalanced forces, unlike balanced forces, unbalanced forces always cause a change in the motion of an object. For example, what causes objects to speed up or slow down? Well, unbalanced forces can cause objects to speed up or slow down. And what can cause the motion of an object to change direction? Unbalanced forces can cause an object to change its direction of travel. In fact, what can we say about another way to say this, or what's another way to say or describe the relationship between unbalanced forces and the motion of objects? And what we can say is that unbalanced forces are necessary to change the motion of an object. If you don't have unbalanced forces, the motion of an object will never change. And so an example, what does a soccer ball experience when it is kicked? Let's say there's a soccer ball sitting still, and then you run up and kick it. What does the soccer ball experience? The soccer ball will obviously move, and so it went from a situation where it was not moving, it had balanced forces, to a situation where it began to move, so its motion changed, and so the soccer ball experienced unbalanced forces when you kicked it. Okay, now we're going to talk about a specific type of force for the rest of our unit. This is what we did this past week. If you throw a football, and football is the example I'll give you here. If you throw a football, does it fly on forever? And whether or not someone catches the football or if it just lands on the ground, the answer to this question, of course, is no, it does not fly on forever. So what we just learned is that, or what did we just learn? What is needed to change the motion of an object? We just learned an unbalanced force is needed to change the motion of an object. So when you throw a football, let's say you throw a football and someone catches it, what force is stopping the football? Because when the football is moving, it has some speed and it has some direction, but then when the receiver catches it, it stops moving. So there has been a change in its motion. So there has to be an unbalanced force that causes the change in the motion. What is the force that changes the motion of the football? The answer is friction. Friction is the force that causes the change in motion of the football. Well, okay, so I'd ask the question this way, if it were to show up on a test, probably, what is a force that opposes motion between two surfaces that are touching each other? And the answer to this is friction. Friction is a force that opposes motion between two surfaces that are touching each other. Now, there are about 5 or 6 different definitions, terms and definitions that have to do with friction, and a lot of them are similar. So this is an area of confusion sometimes for students. So make sure that you have all of these straight in your mind going into the test. Now, if friction increases, what can we say about the motion of objects? Well, what we can say is that the greater the friction, the harder it is to move two objects that are touching. So two objects that are touching each other, the greater the friction is, the harder it is to move those objects past each other. Well, we talk about what causes friction, and this is a little more complex than what we're going to talk about, but The reason that friction happens is because the surfaces of all objects are rough. And if you look at the picture in the upper right here corner of the page, you can see this picture up here. Whoops. This picture right up here, you can see that there are all these little sort of valleys and peaks on the surfaces of objects that have to slide over each other whenever two objects that are touching are moving past each other. Are surfaces, is there any such thing as a smooth surface? And the answer is no. Even surfaces that appear smooth are rough at the microscopic level. Okay, so this will go into the next slide, but there are three factors that affect how much friction there is between two surfaces, and we'll get to this on the next slide. Okay, so here's a list of items here. Whenever you have a list in your notes, you should pay attention because those are pretty easy test questions to ask for me. So what are three factors that affect how much friction there is between two surfaces? So the three factors are surface texture, electrical attraction, and the forces actually pushing the two objects together. So when it comes to surface texture, if the surfaces become rougher, what happens to the friction between the objects? We can say that the rougher the two surfaces, the greater the friction. And this is one of the things that we tested in our friction lab, the what a drag lab, when we were dragging the blocks across the different surfaces. Now, electrical attraction is not one that we did in a lab, that we tested in a lab, but that one was the one I gave you the example of the magnets sliding over different surfaces. So for the electrical attraction, we say that the stronger the electrical attraction, what happens to the friction between two objects? We say the stronger the electrical attraction, the greater the friction. And what happens with when we have electrical repulsion? So that's when we know magnets stick together, but also we know that they push each other apart. They repel each other if you have them flipped in a different direction. So the stronger the electrical repulsion is, this actually can result in what kind of friction? And the answer, or the effect on friction, can be a reduction in friction. And this is the kind of thing that allows these bullet trains that I talked about in class, that showed this example here, to run almost on this cushion of air because the rails are repelling. They actually repel the train, and it essentially lifts the train up on this cushion of air to greatly reduce the amount of friction between the train and the train track. And we talk about forces pushing the objects together. This is another thing that we tested with our What a Drag lab. And so for this one, the forces pushing the objects together, if the force increases, the stronger the force pushing two objects together, the greater the friction is going to be between those two objects. Okay, now moving on, we have two categories of friction. What are the two categories of friction? The first type of friction is, there are two categories of friction. The first type is static friction, and there's the other one, and the other one is kinetic friction. So we have static friction and kinetic friction. Now, when you apply a force to an object, but the object does not move, what kind of friction is occurring? And this is static friction. Static friction occurs when we apply a force to an object, but the object does not move. So what is the frictional force that prevents two surfaces that are touching from moving past each other? This is static friction. And remember, static friction, the key with this is that it prevents two surfaces that are touching from moving past each other. So why doesn't an object move when you're applying a force to it? And the answer is that the object does not move because static friction balances out the applied force. Now, when an object begins to move, can you have static friction anymore? And the answer is no. Once an object starts moving, the static friction disappears, and you get a new kind of friction called kinetic friction, which is the other category of friction. So kinetic friction is what we'll talk about next. So what is the friction between surfaces that are touching and moving past each other? And this is the definition of kinetic friction. Now, this is a definition that is very similar to the definition of friction itself, but it's not the same because we emphasize here that the objects are actually moving. With the definition of friction, we're just saying that the force opposes the motion between two objects that are touching each other. Static friction opposes the motion between two objects to the point where the motion is stopped completely. Kinetic friction opposes the motion, but it doesn't oppose the motion enough to stop them from moving. And that's an important distinction, but it's also an area where people can become confused definition-wise, so don't let that happen. Now, there are three different kinds of kinetic friction. What are the three different types of kinetic friction? The three different types of kinetic friction are sliding friction, rolling friction, and fluid friction. So, what is a type of kinetic friction that opposes motion between two surfaces that are touching and sliding past each other? This is sliding friction, and hopefully this is not one that you would ever get wrong because it has the word sliding in the definition, which is maybe grammatically or technically maybe not correct to do, but that's what we do. So this should hopefully be an easy one to get if it shows up on the test. But it is friction that opposes motion between objects that are sliding past each other. And a couple examples. So give me two examples of where you would see sliding friction, and one example is the brakes on a car or a bicycle, and another example is sandpaper. In the pictures on the right-hand side here of the girl pushing this dresser show these different situations. So next, what is a type of kinetic friction that opposes the motion between a rolling object and the surface it's rolling over? And so logically, this is rolling friction. And rolling friction, and we can think about this with this is very common sense because we use rolling friction all the time. Does rolling friction tend to be more or less than sliding friction? The answer is rolling friction tends to be less than sliding friction. And where do we see rolling friction all over the place? Well, nearly every form of land transport takes advantage of rolling friction because it does tend to be less than sliding friction. What kinds of things take advantage of rolling friction? We can say anything with wheels takes advantage of rolling friction. Bicycles, cars, trains, and ball bearings are all examples that I've given you for rolling friction. Okay, next, what is a type of kinetic friction that opposes the motion of a solid object that moves through a fluid, in other words, a liquid or a gas? This is fluid friction. And again, a definition that hopefully should not be too difficult because it has the word fluid in it. Now, fluids we tend to think of as liquids, but gases also fit the requirements of fluids. So scientifically, gases are considered to be fluids as well. Does fluid friction tend to be more or less than sliding friction? Fluid friction, like rolling friction, also tends to be less than sliding friction. And where do we see fluid friction in everyday life? Where we see friction or fluid friction in everyday life is in lubricants. Many lubricants use fluid friction to make motion between objects occur more easily. So, for example, what's an example of lubricant? Grease is an example of a lubricant that is used to change sliding friction to fluid friction and thereby reduce the amount of friction that is occurring. I think we often have a tendency to think of friction as a harmful thing because it opposes something, it opposes motion. But in fact, it is oftentimes a very helpful thing. So friction can be both harmful and helpful. So friction is both harmful and helpful in our world. So give me an example of a situation where friction can be helpful. And so one example, there's many examples, but one example is that friction between a car's tires and the road allow the car to move forward and also prevent the car from sliding off the road as it drives around a corner. So obviously those are two helpful things where the friction that would prevent the motion between the tire and the road actually allow the car to move itself forward and prevent the car from sliding off the side of the road. Now, give an example where friction can be a harmful thing. And we could say that friction within the moving parts of a car's engine cause the parts to heat up. They cause wear and tear on those parts. And so there's an example where friction can be harmful. Give another example where friction can be harmful. Another example could be where friction causes holes in your socks, just from your socks rubbing on your shoes, or on the ground if you're not wearing shoes, can cause holes to form in your socks. However, one more example where friction is helpful. Friction is just necessary for us to even walk. We would not even be able to walk. We would slip and fall every time we tried to walk if there was no friction. The way that we walk is by taking advantage of the sliding friction, or actually it'd really be static friction between our feet and the ground. So as we push down and backwards against the floor, we are actually able to push ourselves forward because our feet don't slide on the floor. Now, because friction can be harmful or helpful, sometimes there are situations where we want to increase friction or we want to decrease friction. So we can look at ways to reduce friction. One way to reduce friction? One way to reduce friction is through the use of lubricants. So give some examples of lubricants. So we can say motor oil, wax, grease, and gas. And in this case, I mean gases like the air around us. So what's an example where gases can be used as a lubricant? And this is one that I'm sure most of us have experienced before, and that is an air hockey table uses gas as a lubricant between the hockey puck and the table. Another way to reduce friction. What's another way to reduce friction? Another way to reduce friction is by switching from sliding to rolling friction. This is another way that we can reduce friction as well. So what's an example of switching from sliding to rolling friction? And I gave this example in class and it's in your notes. When the pyramids were built thousands of years ago, the pyramids are in the middle of the desert, and so there's lots of sand in the desert, and they're made of these enormous blocks that are like half the size of our classroom. And so those blocks would be pretty hard to drag through the desert sand. So the idea or the thought is that that when they were building the pyramids, they put them on top of logs and rolled them over these logs, and that allowed them to move the blocks through the desert more easily. So it's easier to build a pyramid when the blocks are pulled over round logs as opposed to over the desert sand. Okay, so there's a couple examples, one of thousands of examples of reducing friction. Now, other ways that we can increase friction. So, in some cases, friction is helpful, in many cases, and we want to increase friction. So, if you remember last year we had the big winter storms, and the first I've seen in Alabama since I've been here for 12 years or so. So what do you do when there's ice on the road? Well, one of the things that people do, there's a few things that we do. One of the things that we do is we put sand on the road, and putting sand on an icy road allows that sand to become embedded in the ice, and that increases the friction by creating a rougher surface than just the ice, which is a very smooth surface and therefore has very low friction. So sand scattered on icy roads helps prevent cars from skidding around by increasing the friction by making a rougher surface. And this is sort of just an everyday kind of example that you probably would never even think about. But when you wash dishes, and hopefully you wash dishes sometimes, when you wash dishes, pressing down harder on the dish increases the force between your two surfaces, and that is another way that we increase friction to get some work done to help to remove some food, like this dirty pan in the picture here. You got to press down harder on the sponge to get all that food up. Now, so that's just two examples of many examples of how we could, ways we could increase friction. Okay, I think that is it for the notes, and I'm ready to stop talking with my nose. So hopefully this is helpful for you as a review. Your test will be tomorrow. I think that we spent plenty of time on this, and you will all do fine. All right, bye.